Hello friends, in this lecture we will cover the next topic of our unit number 6, that is FM transmitter and receiver. Now the learning outcomes. Now after studying this topic, student will be able to understand first what is frequency modulation or what is FM technology. Then the block diagram of FM transmitter and the block diagram of FM receiver. Now what is frequency modulation? Now before going to the frequency modulation, let's revise our concept, that is what is meant by modulation. Now modulation is nothing but what? The high frequency signal or carrier signal which is required to carry the low frequency signal or baseband signal or the information or the message signal. So in amplitude modulation, in last lecture we have covered the first type of modulation technique, that is amplitude modulation. In amplitude modulation, the amplitude of the carrier signal will change in accordance with the amplitude of the low frequency signal or the information signal by keeping the frequency and phase constant. Means in amplitude modulation, amplitude will vary but the frequency and the phase of the carrier signal will be constant. But exactly opposite in frequency modulation. In frequency modulation, or the frequency modulation is a system of modulation in which instantaneous frequency of the carrier signal or high frequency signal is continuously varied in proportion with the instantaneous amplitude of the modulating signal or the low frequency signal. Means here the frequency of the carrier signal will change in accordance with the instantaneous value of the modulating signal or the low frequency signal, and the amplitude of carrier signal will remains constant, so the information is conveyed via the frequency changes. Means in frequency modulation, the remaining two parameters, that is amplitude and phase, will remains constant, only frequency will change, so the information will be conveyed from transmitter to receiver in the form of frequency changes, and this technique is nothing but what? The frequency modulation. Now let us see the block diagram of frequency modulated transmitter. Now if you observe this block diagram, then we require the crystal oscillator, then phase modulator, then the audio source, then the frequency modulator, and finally the transmitting antenna is connected with the power amplifier. Now the FM transmitter also works as same as that of the AM transmitters. The frequency modulation can be generated at any point including the radio frequency source, and accordingly we can use the direct or indirect method for the generation of frequency modulation or for the generation of FM. Now this block diagram shows the FM transmitter, that is Armstrong FM transmitter. Now in block diagram the crystal oscillator is used which will generate the stable carrier signal, and the modulating signal and the carrier signals are applied to the phase modulator to generate the narrow band waveform or narrow band frequency modulated waveform, that is NBFM, that is narrow band frequency modulation. Then the NBFM, that is narrow band frequency modulated waveform, when it is passed through the frequency multipliers, then it will increase the frequency deviation and the carrier signal frequency to the appropriate level, and the output of the frequency multiplier stage will be WBMFM, that is wide band frequency modulation, but it is at low power. Means the output of your frequency multiplier, it will be converted from the narrow band to wide band FM, but it has low power level. So to convert that low power level into high power level, we will require the power amplifier. So this WBFM is then passed through one or more stages of power amplifier to boost the power level, and finally this wideband frequency modulated waveform is transmitted by using the transmitting antenna, and this is all about the block diagram of FM transmitter. Now let's see the block diagram of frequency modulated receiver or FM receiver. Now this block diagram of FM receiver is again similar to our AM receiver, that is amplitude modulated modulation receiver, and here the two blocks, amplitude limiter and de-emphasis network, are included before and after the FM demodulator, and the operation of remaining blocks is same as that of our AM receiver. We know that in FM modulation the amplitude of the frequency modulated waveform will remains constant. However, if some noise is added in FM in the channel, then due to that the amplitude of FM wave may vary. Thus, with the help of amplitude limiter, we can maintain the amplitude of FM wave as constant by removing the unwanted peaks of the noise signal. And in this process, the de-emphasis, that is low pass filter, is included after FM demodulator, and the signal is passed to the audio amplifier to increase the power level. Finally, we will get the original sound signal from the loudspeaker, and this is all about the block diagram of the FM receiver. Now, which are the different advantages, disadvantages and applications of frequency modulation? First of all, FM is suitable for the quality music transmission, means for music transmission you can use your FM technique. Similarly, FM technique is less affected due to the man-made noise. And if you see the block diagram of our FM receiver, then you will observe in the block diagram of our receiver we are using limiters. Now these limiters are used to remove the amplitude variation produced in the signal due to the noise. So these are the various advantages of the FM technique. Similarly, there are some disadvantages are also of FM technique over the amplitude modulation. That is, first, it requires the large bandwidth, and FM transmitters and FM receivers are complex and costly as compared to amplitude modulation or as compared to AM. And there are some applications of our FM, that is, we can use our FM for the radio broadcasting, then we can use our FM technique for sound broadcasting in TV system. Similarly, we can use our FM technique in police wireless or walkie-talkie and ambulances. So these are the various applications of FM. Thank you.